All right, thank you everybody. Thanks for coming to my presentation. So yes, like Chris said, I'm going to talk to you about EVA, or Enhanced Video Archive. And to just jump into it right away, when you are talking about clients that are big corporations that have a lot of legacy materials recorded in videos, they need an efficient way to use that material in future. So in a company like mine, we have a lot of legacy training videos, a lot of HR manuals, kind of how to use internal software, subject matter material, which is stored in the videos. And what that usually looks like is there is a folder on some kind of a shared drive with a bunch of MP4s in it. And the company, in a lot of cases, would like to have something like a recipe lookup. So when you're cooking and you look up a recipe, you see instructions on how to do things interspersed with videos that are kind of timestamped, so you can exactly jump into the point of the recipe and see the technique that the chef demonstrating is using. And so this application is aimed to build that for a corporation like my own. So corporations potentially want this application, but what they really care about are things that are beyond or underneath this application. They like to protect their data. They're worried about their trade secrets leaking out, or even just anything that they have internally. Companies are usually protective about that. They would like to prevent misuse of their tools. When they're using a tool, and especially corporations and companies that are kind of more in traditional fields, not in software development, they have a mistrust of AI and large language models. And so they want to see the outputs referencing back to the original context so they can see that there's no hallucinations. This is doubly important in situations where a company works in a regulated field, where them issuing a recommendation might result in a lawsuit or even injury and death or loss of property. And finally, companies that are not software-first companies don't want to buy a whole AI department just to run a video search. They want no-hassle deployments. They want to put an app on a laptop and point it at their folder and see if it works or not. And so in my application, I was trying to address all of these things. So in short, the user types up a question, and in this demo, you will see that the question is basically piped into two branches. One of them searches across transcripts of videos in our database archive, and the other one searches through some kind of an internal knowledge store. As an example, for the demo's purposes, I was using Adobe Photoshop training database of videos with their transcripts, and then the corresponding internal knowledge store would just be the Adobe's website with help and support, for example, for Photoshop. In the end, this is compiled in a recipe-like interface for the user. So switching to the demo. The application has already been initialized here, and so I might type an answer, type a question like, what are layers? And so we will go through what these steps mean, but the application is working through understanding the query, pointing the query at both the transcript archive and the external knowledge store, and then compiling them in a response. So what you see here on the screen is the response that the user would be reading. Layers in Photoshop are like transparent sheets stacked on top of each other, so on and so forth. What is different about this compared to if you type that same question in the chat GPT is that you're getting here references to the exact videos that were used to generate this answer. And even more so, you actually get to a particular timestamp that video, so you can view that video back and forth, right? And you can see the context surrounding your answer. We didn't ask a very specific question. We just asked what are layers. So 3 different videos here get organized with layer groups, replace a background using a layer mask, and understand layers. We're all presented to the user. And obviously, we can configure how many of those we might want to get. Similarly, the websites that were used to generate are here introduced as screenshots first for kind of quick overview for the user, but the user can obviously click and go and visit that website, again, to build transparency, to build trust that this application is really using the existing data stores rather than hallucinating the answers. If we go with a slightly different query, for example, where is Paris? We're going to see what the app does. It answers much more quickly. It says the question is not related to Photoshop, and this is my specialization. Thank you for playing. Good night. So these are the two kind of basic cases that I wanted you to see in the presentation, because they really relate to two different paths through the architecture that a message might take. As you can see here, these are different stages, and you will notice them and recognize them from what we were seeing on this being outputted on the screen. At each stage, the message is either routed to the research or to kind of not relevant branch. And at each stage, the nodes are pinging the OpenAI's APIs and using their LLMs to generate the output. So again, we check for relevancy, go to research stage. Research stage writes queries for the search of the help and the search of the transcripts. A complete check is performed, and if the amount of material is incomplete, meaning the query can't be yet answered, it goes back to research, and this cycle can repeat several times until enough context is retrieved, at which point the writer writes the answer for the user. You see here, in addition to OpenAI, Tavily is used as the search interface, and Quadrant is used as the vector database storing the context. Now, we talked about what companies really care. So one thing that I mentioned is that they care about protecting their data. They don't want a question about their data, even through the backend, going to OpenAI's API. So this app was built so that at the throw of a switch, all of the calls to LLMs can be rerouted to an on-prem deployment of large language models. In my case, Ollama, but it's easy enough to use any others. And at that point, if I'm demoing this on customer site, I can turn off their Wi-Fi, unplug their network connection, and show them that this still works, right? And that's the primary thing that the companies like mine and like others care about. If the data is leaking, they don't want to even try it out. So this is the first step in building the relationship with this company. We see some guardrails are implemented here to thwart misuse. A simple guardrail was basically just a relevancy guardrail, and here it is implemented through a prompt. Basically, the LLM is checking whether the prompt is relevant to the Photoshop database. The guardrail that I didn't show in the interest of time is an additional step that can be enabled, that the user is presented with a query that goes to the external website before that query is sent there. So in our case, the query might have been, what are layers to the Adobe search? The user would be presented with an option of actually declining that search, therefore making sure that even if they do need to access some internal information, they know exactly, and they can decide exactly at the time whether they want to do it or not. The trust is built by providing references to the original material, and in my case, this was quite a bit technical. Those phrases in a whole that can be then semantically chunked and retrieved, and propagated the timestamps through a particular workflow had to be completed to do that. But in the end, like you saw. We saw that the answers all linked back to the original videos. Finally, the deploy anywhere can be enhanced by basically building a custom transcription, visual semantics, and an OCR model assembly that would ingest the set of folders from MP4 and do the same thing as this demo set would do for us in any user's application. So in future, that is one big step that needs to be built, but additional enhancements could be added to the application, like interfacing with speech or structure the responses in, for example, for developing instructional material. And in the end, I hope you enjoyed my presentation. This was an enhanced video archive that additionally aims to protect the data, guard against misuse, and build trust and transparency to be able to enhance the video archives that large customers have in traditional industries. Thank you very much.